Okay, Yoki doki. Welcome back to class. And today we'll take a pause from mathematics. I have a lot of video on mathematics I will upload in a short time. However, I promised some of our followers that we're going to look at physics today. So I'll start from the scratch, from the basics, physics. And let me say this quickly. No matter what your foundation is in physics, I can tell you for sure, you follow us consistently and judiciously, you won't miss anything. You won't miss, even if your physics has been wobbling or you've not had a fantastic period during physics classes, or if you had, left school and you are still finding physics very difficult, please share this video with your friends and family. Trust you that you will regain that strength and that confidence again in physics. I remain your humble um, Paddy on this one, your humble G on this one, E for short. Okay, so we'll be looking at dimensional analysis today. I'll make it very simple, light. The topic is a bit broad, but I'll try to cut it a bit and see how much you can cover in just two classes. Okay, two classes no less than 10 minutes. Two classes no less than 10 minutes. So please follow up and check next episode as it came. So let's start quickly. All right, dimensional analysis. So now, for you to solve dimension analysis, you need to understand quantities, okay? And quantities is divided into two, basically. Now, previously it was into three categories, but now the general thing is into two, which is fundamental quantity and derived quantity. Now, these two quantity are the basics of all other quantities we have in physics. Okay. Now, what is a fundamental quantity? A fundamental quantity is a quantity that serves as a basic form of quantity. Is a basic form of quantity. Why derived quantity are quantities that are derived from fundamental. Without fundamental quantity, derived quantity cannot stand. Okay, without this guy cease to exist. So derived quantity are built based on fundamental quantity. So how many fundamental quantities we have? We have seven. Seven fundamental quantity, and they are mass, length, time, temperature, electric current, luminous intensity, and amount of substance. Okay, those are the seven fundamental quantity that we have. We have mass, we have length, we have time, we have temperature, we have amount of substance, we have electric current, and we have and luminous intensity. So the last one is luminous intensity. Okay, so now out of these seven, what we need is these three to do dimension analysis. Just these three to do dimension analysis. Why? Because they are the basic, they are the most important form of dimension analysis, which is mass, length, and time. And we call them MLT. Now, their units, the unit of mass is kg, the unit of length is meter, and unit of time is seconds. So why we use MLT for dimension analysis, we use kgms for units to calculate units. Kgms to calculate units and MLT to calculate dimension analysis. So now let's get that. Now, what this means is that any other quantity that is not here are called are called derived quantity. These are your basic what? Derived, fundamental. These are your fundamental quantities. These are your fundamental quantities. And anything outside this, any other quantity outside this guy, these seven are what? Derived quantity, which means your force, your velocity, your speed, your electric current. Your movement, momentum, every other quantity falls under what? Derived. Now, so that being said, now this are what we use to calculate the dimension analysis. Now let's just quickly start off something. For example, if I ask calculate dimensionalities of speed, calculate dimensionalities of speed. Now there are various steps you need to know while calculating dimensional analysis. Okay, there are various steps you need to know. Number one, you need to know the formula of the quantity. You need to know the formula of the quantity. Number two, you know the formula of the quantity of that quantity you are looking for also regarded as a quantity. They also regarded as what? Quantity. And they could be derived. Mostly they are derived. However, once you know the formula, you must also look at those quantities. Do they also have a formula? If they do have, you have to put it there. Okay, until you don't have a formula again, then thereafter you can now apply MLT. Now let's get on to business. For speed, the first step, what's the formula for speed? Formula for speed is what? Distance over what? Time. Now the question you need to ask yourself again is, second one is that, does distance have a formula? Does distance have a formula of its own? No, except you cross multiply to make, so distance does not have formula of its own. So that means that this does not have a formula. Does time have a formula on its own? No, except you cross multiply, make time subject of formula. So however, on their own they don't have formula. So that means that both quantities don't have what? Formulas. Therefore, at this junction, you apply what? MLT. Now, applying MLT means that your speed is equals to distance. How do you measure distance? Do you measure distance in terms of mass, length, or time? Your guess is as good as mine. Length, right? Length. So that means that distance is what? L over. How do you measure time? Of course, T, time. Now, this junction, a bit of mathematics is required. Now, you agree with that in mathematics, um, if I have A over B, A over B is same thing as saying A times 1 over B. Okay, A times 1 over B. That means I've differentiated this, I've expanded this to be this. So that means that A times 1 is what? A over B. So it's the same thing as this. So I can write this guy, using this principle, I can write this guy as L times 1 over T. Now again, using mathematics principle, if I have 1 over A, the same thing as what? A raised to power minus 1. That's your inverse rule. So since I have 1 over T, I can write this guy as 1 times T raised to power what? Minus 1. So definitely the final answer for your speed is LT minus 1. That's the dimensional analysis for speed. However, if I need to calculate the units of speed, okay, that means the same step. First thing, what's the formula of the quantity? Second step, if the quantity does not have a formula again, you apply kgms. Okay, now you come speed. How do you measure distance? In terms of kilogram, mass, or seconds? Of course, is mass over your time. How do you measure it? In terms of kilogram, mass, or seconds? Of course, seconds. So that means that, so you follow the same step. This is m times 1 over s. This is ms raised to power minus 1 as a final answer, which is synonymous to this. Let's look at a further a question that will require us to do more. Okay, let's look at force, for example. Force. Now, like I said, you need to know the formula of that quantity force. So what's the formula of force? Formula of force is what? Mass times what? Acceleration as a formula. Now, you now go back to the formula. Does mass has a formula? No. But acceleration has a formula? Yes. So, what is the formula for acceleration? So, you say, but acceleration is equal to what? Change in velocity over what? Time. Now, having said that, I can replace acceleration with this guy to substitute this formula for this guy here. So, therefore, force is also equal to what? Mass, because this is all have the formula, of course, times change in velocity over what? Time. Now you come back again to this formula and check. Does mass has a formula? No. Does velocity has a formula? Yes. So then you also say that velocity is equals to displacement over what? Time. So replace velocity with this guy. So that means that force is then equals to mass times, instead of writing velocity, we're going to write this displacement over time. This is for velocity. Then over this time. Now don't get it twisted. What I've just done is just to replace, because this doesn't have a formula, this doesn't have a formula, but this has a formula. And the formula for this is this guy. So what I just did is just substitute the space over time for velocity only, still leaving my time here. So mass, so writing velocity, I replace it with the space over time, which is velocity over then time. And the next step, you come again to check. Does mass is a formula? No. Displacement, that's a formula. No. Does time has a formula? Nah. Does time also has a formula? Now then at this junction, we can apply MLT. So force. How do you measure mass? MLT, of course, mass times displacement. Now, if I should throw this duster from here there, okay, it has covered a particular, I've displaced it, a particular distance. So why do I measure the displacement? Is it in terms of mass, length, or time? Good. Okay, it's as good as mine too. Length. So L over, of course, time is time. Then over, don't forget this time, T. Beautiful. Then from here, the agreement, I can say that M times L times 1 over T over T. Don't forget this guy is not cutting across everything because it's only limited to here. Don't forget the way we started. So it's not over everything. Now, the agreement that this guy can write this guy as M times LT minus 1 from the way we did this over T. Now, this junction, we have to apply a basic principle in mathematics, which is indices. Now, we know indices that if I have a raised to power x over a raised to power y indices, since they have the same base but different power, I'll pick one of the base, a, then subtract the power, x minus y. So I'm going to apply the same thing here. Okay, I'm going to apply the same thing here. So which means that since I have tt, I'll pick one t. Then I have m, that means force is equals to m times L. I pick one t. T. This guy has minus 1 here. Minus 1. I'm dividing. I'll subtract. Division means subtraction from indices. So same thing also apply here. Then this t has an invisible power of 1 here. I hope we know. This guy carry 1. They carry 1 for head. So 1. So you put 1 here. Good. Then from here I can multiply it to have force is equal to m L T minus 1 minus 1 will give you minus 2. Minus 1 minus 1 will give you what? Minus I have minus 2. Final answer. Boom. So I give you the to do in terms of units for force. At the end of the day, you will have for your force, if you are doing in terms of your units, your answer should be F equals to kg ms. So if you got this, then your answer is correct. Please comment, in the comment section below if this is your answer. So at this junction, we're going to stop for today. For doing this, because this is the basic one. So if you see any question if you come across any question as to get dimension analysis, this is what you're going to do. First of all, look at the quantity, define it, the formula. Once you have done that, look at the formula. The formula also has formula. Until all the quantity does not have a formula, again, I can apply MLT. Let me just give you something to do at home as assignment. Please find time to find dimension analysis for the following. Just play with density first. Density. 2. Let's play with stress. And finally, let's play with momentum. So what do? Density. Formula for density. Check, does the formula has a formula? If they do have, break it down to when nothing again, they apply MLT. Same thing with stress. What is the formula? Look at the formula. Do they have formula? Break it down to when there's no